Alrighty, so today we're going to talk about something called the natural log. Okay, the natural log. And what the natural log is, it's log base E. Log base E. Okay? That E, this E right here, this is called the natural number. It's called the natural number, and it's approximately equal to the value 2.718. But it's an irrational number. What's an irrational number?
It keeps on going for a really long time.
Yeah, the decimal is never ending. It cannot be written as a finite fraction or decimal. So it's like pi in the sense where it's a number, but we represent it with a symbol. Okay? So E is our natural number. The reason it's often called the natural number is because E shows up in a lot of natural processes. Okay, you'll see it in a lot of different ratios and things. If you Google some of that, it's really interesting. So log base E is the natural logarithm. It's written, instead of writing log base E, it's often written ln, either in kind of cursive or italicized. Okay, you'll often see me write it like ln just because that's kind of how I write my L's sometimes. So just know that that's what that is. But I'll try and do the loopy L. Just doesn't always happen. And it's so this is how you would write it, but this is what it implies. It implies that it's log base E. And the way again that you say it is the natural log.
Is that LN or LM?
ln. All right, so the inverse of ln of x, or the natural log of x, is e to the x. So we're going to plot those two functions. Let's start by plotting e to the x. Now that is an exponential parent function, right? It is. Good. So what do we know about exponential parent functions? Where's their asymptote? Y equals 0. And what point do we know is on them? 0, 1. The next point would be 1, comma, 2.718, blah, 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 right? The approximation of the natural number. Because e to the first power is just going to give you e. So that's our e to the x parent function.
Oh, so you, since you don't know really the other numbers, you just draw 1 or 2 and go.
I mean, we could plot more. But it's just another exponential parent function. Just like 2 to the x, 3 to the x. This is e to the x. It's another parent function. Okay, now let's plot the natural log of x. Okay? Or the ln of x. All right, that is just a log parent function. What you're thinking is y equals log base e of x, because ln stands for log base e. So where's the asymptote in a log parent function? X equals 0. What's a point that we know is on every log parent function? 1, 0. And then we'd have another point at approximately 2.718, 1. All right, what's the domain of our exponential function, e to the x?
Numbers.
All real numbers. And what is the range? Okay, what about for the natural log of x? The domain is going to be 0 to infinity, and the range is going to be We have infinity to infinity. So what do we know about these two functions? They are what? These are inverse functions. So we have y equals e to the x and y equals log base e of x, or what we call y equals the natural log of x. Just like if I had 2 to the x, the inverse would be log base 2 of x. Yes? Yeah, Sophie.
Is there a name for y equals e to the x? Like the.
It's just another exponential parent function, e to the x.
Was it L?
Yes. That's why I said I kind of forget my loops sometimes, but know that that's what I'm writing, is I'm writing ln.
Is it supposed to be like the loop? Or
I mean, it's a cursive ln. I just have, that's how my handwriting is.
okay, but is it fine if it's like underlined in the green one? Like how it's-
Yes. Okay, so I want to write the transformations that have been applied to the parent function to give us the equation y equals the natural log of x minus 3 plus 1. So what's the parent function?
I think the log function
Good, y equals the natural log of x. So what have we applied?
is right 3.
Right, 3, up 1. Okay. We're given the graph of y equals e to the x plus 2, and we want to reflect that across the x-axis, shift it up 1 unit. What will be the equation of the new image? So what creates a reflection over the x-axis?
Negative.
Negative where?
Before D.
Yeah, before our base. So it would be the opposite of e to the x.
Plus.
And then if I want to go up 1 unit,
Oh, wait.
hang on, I've messed something up. Sorry. When you do this, sorry. That's why I shouldn't. Okay, when you take the reflection, you're actually reflecting this whole graph. So technically, when we take this reflection, we're doing the opposite of e to the x plus 2. Because we're taking our whole exponential function that had been moved up 2 units, and we're reflecting that whole thing. So it's going to be further down here. Does that make sense? And then we're going to shift it up the 1 unit. So let's see what we would do. If we could distribute this negative, do you see that we'd have g to the x equals negative e to the x minus 1? Because it'd be minus 2 plus 1, which gives us e to the x minus 1. So let me show that graphically for some of y'all that, yeah, sorry.
I've never done that.
That's a good question. I'm being honest. These are the types where sometimes I think I understand the purpose of the question, but I don't always think they're good questions because I don't always think it's necessarily the way you would actually go about doing it.
Okay.
So to me, I take these questions as more an application of the process.
Okay.
So graphically what happened is we reflected this whole graph across the x-axis, which moved, this was at 1, 2, 3. So this is going to be down at negative 3. So the graph went like this. And then we went up 1 unit, which put it right there. So personally, I think this is a better way to think about it graphically. And maybe we should have been doing that the whole time. Okay. Everyone okay with that? I know it was kind of weird. Are we okay with where we ended up? Okay. Now we're going to do some simplifications. I can ask you to work with either on a non-calculator or a calculator section. Sometimes I'm going to want your answers in terms of E, so it would be a non-calculator. We're also going to practice actually coming up with estimation values of these problems. Okay, so let's start here. If I have E squared times E cubed, yeah, E works just like another base. If I had 2 squared times 2 cubed, that would give me the same as 2 to the 5th. So this is E to the 5th. All right, look at 5. 3 times E to the negative 4th, that quantity squared, times E squared. What would I do first?
I distribute the square.
Okay, if I distribute the square, what am I going to get? 9E to the negative 8th power. Times E squared. Okay, what would we do next?
Negative 6.
9E to the negative 6th, because we add our exponents. But do I like to leave negative exponents? No. So how do I rewrite this without a negative exponent? Okay, so keep the 9 on top, so it'd be 9 over E to the 6th. All right, the natural log of E. Okay, what did I define the natural log as to you? Okay, so could I rewrite this as log base E of E? That's what natural log is, right? It's log base E. Okay, well, what do we know if our base and our argument are the same? It's 1. This is a property you want to memorize. The natural log of E is always equal to 1. The reason is it's log base E of E. Everyone okay with that?
So you have to write like log base E equals 1 if you were to give the answer.
No, the answers to this problem is 1. Okay, look at 7. Anyone have an idea on how to start this? We're going to work it a couple different ways.
You put square L log E plus or log E.
Okay, what do you want to do?
You gotta put log E1 and log E minus log E4.
Okay, so you're expanding this. You don't have to rewrite as log base E. You want to try and train your brain. When you see natural log, you think log base E.
Oh, 1 minus.
So I'm going to write this as natural log of 1 minus the natural log of E to the 4th. Is everyone okay with that? If it's really confusing to you, then go ahead and write log base E of 1, log base E of E to the 4th. But we've got to try and practice. Okay, what is the natural log of 1? 0. Why? Yeah, anytime you have an argument of 1, that's always 0, right? So this is 0 minus. Could I bring this 4 to the front? So 0 minus 4 times the natural log of E. Well, what did we just figure out that the natural log of E is? 1. So this is 0 minus 4 times 1, which gives us negative 4. Okay, let's work this one other way. Would you agree that I could have written this as the natural log of E to the negative 4th? Is 1 over E to the 4th equivalent to E to the negative 4th? Yeah. And then could I have pulled that negative 4 out in front? So I would have the natural log of negative 4 times the natural log of E?
Yeah.
Which is still what? Negative 4. Because what is the natural log of E? 1. So negative 4 times 1 is negative 4. All right, we've got E to the natural log of 6 power. All right. What are your thoughts?
Like, you know, there's yeah. And I don't know how to say it.
Okay. We could, but it's going to get us to the same place of a rule that we've already come up with. Would you agree that you could think about this as e to the log base e of 6 power?
Yeah.
So think about it this way. What do we know when the base of our exponent and the base of our log are the same?
Oh, it's the argument.
It's the argument. This is just 6. This is from that property that you learned that b to the log base b of a power is always equal to a. Which means that we now have a new property, or a version of that property is e to the ln of a is always going to be what? A. All of our rules still apply because natural log is still a log. So all of our log rules still apply from earlier in this unit. All right, we want to solve for x. So look at number 9. The natural log of x minus the natural log of 2 is equal to 4. What would we maybe do first? Condense. If we condense, what are we going to have? Natural log of x over 2 is equal to 4. Okay, what base is implied here? E. So how could I rewrite this? E to the 4th is equal to?
X over 2.
X over 2. To solve for x, what would I do?
Times 2.
Multiply both sides by 2. So I would get 2 times e to the 4th is equal to x. Okay, on a non-calculator portion, this is your answer. Just like if I asked you for the area of a circle and left in terms of pi, you'd give me 46 pi. Okay? On a calculator portion, we'll go ahead and evaluate for rounding to 3 decimal points. So, on your calculator, there is an e to the x button. It is right above natural log, and it's in blue. Do y'all see that? If you do second natural log, it gives you e raised to a power. So we want e to what power? 4. We want that whole thing times 2. I don't know why I entered it in backwards. You could have done 2 times e to the 4th. Same thing. And what do we get? Good. Go ahead and always round to the thousandths place. So this will be 109.196. So this step right here is the non-calc answer. This step right here is the calculator answer. So you want to be practicing both. Okay? So you want to do the algebra to get your x isolated, and then go to your calculator, because I could ask you for either of these answers. Is that making sense? All right, let's look at 10. The natural log of x is equal to 5.4. What would we do?
X equals 3.
Okay, if we put it into an exponential, what do we have? E to the 5.4 power equals x. So non-calculator, we'd stop right here. Calculator answer, go ahead and get your answer and round to the nearest thousandths place. Yeah, Sophie?
I thought the ln stands for log of e, so where's the log from?
We rewrote this log equation as an exponential equation. Base e is implied here, so e to the 5.4 power is equal to x. All right, what'd you guys get? All right, will you please try number 11? All right, what'd you get?
32.
Good job. Questions on that one? Is everyone able to get that answer?
Yeah.
Okay, cool. All right, let's look at 12. Okay, keep our goal in mind. What's our goal? To solve for y. Okay, what will we do first? Subtract 3. So this would be 3 times e to the 2y minus 1 is equal to 3. Then what? Divide by 3. So we would get e to the 2y minus 1 equals 1. So we have two options here, yes. First option would be to rewrite this as a log. If we rewrite this as a log, we get what? Log base e, or natural log of what? 1 equals 2y minus 1. Okay, what is the natural log of 1? 0. So 0 is equal to 2y minus 1. So 1 equals 2y, which means that y equals 1/2. Okay, from here, e to the 2y minus 1 equals 1. We could have also gotten the same base. How could I rewrite 1 as e raised to a power? E to the 0 power. And then what are you allowed to do?
2y minus 1.
Yeah, set your exponents equal to each other. We get to the exact same place. I don't care which one you use. But I just want you to see that there's some different paths that you can take here. Questions on that? Okay, one place where the natural number, oh, not what we want. One place where the natural number comes up a lot is in when your interest is continuously compounded. Meaning instead of getting interest on your bank account like every month or every week, you're getting it all the time. And they've calculated that that can be represented by an equation called the continuously compounded interest equation, which has an e in it. So the way we write that is a equals p times e to the RT power, PERT. Okay. A represents the amount of money in your account after T years. Put a star by that, years. Your time has to be in years. Cannot be months, cannot be days. It has to be converted into years. Okay? The P stands for the principal. What does that mean when we're talking about money? Yeah, what you start with. The principal is the money you start with. And lastly, we have R. What do you think that is? Yeah, the interest rate. And the interest rate always must be written as a decimal. So your time must always be in years, and your interest rate must always be as a decimal. Okay. We want to know what is the amount of a $1,000 investment after 10 years if 5% interest is compounded continuously. When you see this word continuously, that signifies to you that you're going to use this formula. I'm going to show you other formulas as we move through our application days. But anytime you see that word compounded continuously, that means we're going to use A equals P times e to the RT power. We're going to use PERT. Okay, let's figure out what they've given us and what we're asked for. What are we asked for? Okay, we're asked for the amount, so we're looking for A. What are we given? Okay, what's P? Okay, P is $1,000. What else are we given? R. What are we going to need to do to use 5% as R?
0.05.
Good. We're going to use R as 0.05. And what else are we given? 10 years. This is T. Okay. So we've got that A equals P, which is $1,000, times E to the RT. So 0.05 times 10. Okay. Some of you have a calculator where when you raise to a power, it doesn't go up high. It just gives you the little caret, right? Some of y'all have that? Okay. If it just gives you the little caret, please make note of these parentheses. If you just have the caret, you have to remember those parentheses. Okay? So it's a good practice for all of us, but I'm just throwing that out there. All right, let's calculate this. So I have 1,000 times E to the 0.05 times 10 power. What do we get? Good. Now, when we're talking about money, are we going to round to the thousands? No, what are we going to round to? The hundreds, because we're dealing with dollars and cents. So this gives us $1,648.72. Any questions on getting that? Okay? All right. Let's look at the last one. I'm going to rewrite our formula since I had to move the slide. Okay. Find the time necessary if you want $1,000 from an initial investment of $750 compounded continuously at an interest rate of 8%. Okay, so I see this keyword continuously, and that tells me I'm going to use this formula. Okay? Okay, what are we looking for? Time. This is what we're looking for. We don't know time. What is the 1,000?
A. Oh, wait, yeah.
It's A, because it says if you want to get this from this.
Don't you add them together then?
The way I read it is that you want to get your account up to $1,000,
Oh, okay.
not earn a thousand on top of it. Okay, what else are we given? Initial investment of P, and what else?
R.
Rate. What do we need to do for the R?
0.08.
0.08. Okay, so we're going to solve this two ways. First, we're going to solve this algebraically. And then I'm going to show you graphically. Okay? All right. Let's go ahead and fill in what we've got. So we know that we've got 1,000 is equal to, what's our principal? 750 times E to what? 0.08 T power. Is everyone okay with that? Okay, our goal is to solve for T. So what would we do first? Divide by 750. Okay, so I'd have 1,000 over 750 is equal to E to the 0.08 T power. Trying to solve for something in the exponent. So what do I rewrite this as? A log. So log base E, so that's the natural log of what? 4/3 or 1,000 over 750 is equal to what? 0.08 t. Is everyone okay with that? Okay, so what would the last step be?
Divide by 0.08.
Divide by 0.08. And at that point, you're ready to go to your calculator. So let's see what that would look like. The natural log button is right where we were using the E. So we're going to do the natural log of 4/3. And we're going to divide that by 0.08. And what do we get?
3.5.
You should get 3.596. Everyone okay with that? If it doesn't tell you to round to the nearest year or anything like that, I would just always round to the nearest thousand.
I found a 2.6.
Okay. Do not round in the middle. Like, you would not have wanted to use like 1.3 or something for the 4/3, or even 1.33. Okay? Don't round at any time till the very, very end in these problems. Okay? All right, let's talk about how to do this graphically. Graphically, I would use 1,000 as y1, and I would use the other side as y2, and I would find the intersection point. That's not always my preferred method because I get frustrated messing with my window, but I know that some of y'all like doing that, so let's give it a try. So I'm going to put 1,000, and I'm going to put 750 times e to the 0.08 t power. Okay, now when you just graph this like normal, like Zoom 6 it, you're not going to see very much. Yes?
One of my friends told me that if you go to Zoom and you go down to 0, it just immediately puts it to fit the graph.
Yeah, Zoom Fit can be a really good tool to try. It's not always going to be a good representation of what your graph is, but it is a very good tool to try. So let's try that. If you press Zoom, and then you're looking for Zoom Fit, it's 0. And it'll reorient your graph. Now you do have to be careful if you're trying to get an idea of what the big picture looks like. But if you're just trying to kind of find where they cross, that's a great tool. Okay, how do I find this value? What do I do? Second, calc 5, enter, enter, enter. And there's that 3.596 years again. The y is the y value that we should have in common. Yeah, Liam?
Do you have to find it? Can't you just do second calc 5, enter?
If you don't see the intersection point on your screen, your calculator will say no sign changed when you try and find the intersection point.
Okay.
Other questions? All right, let's get started on our homework.